Hello, it's Mr. Underwood here, and look, in this video I'm going to go through a few things. I'm not going to go through all of gallery of graphs, but in the extracurricular program last year, I believe that most of you have done all of this, and I guess are working your way through the tail end of circles and semicircles. So in this video, I'm going to go through a gallery of graphs. I'm going to, in particular, talk about just the three. We've got rectangular hyperbola or hyperbolae. We've got the truncus graph and the square root graph. So I'm going to go through just a sort of a few examples, one of each, and we're going to look at the transformations. And that's a really important thing, is no matter what graph you're sketching, it has a standard form, and within each of these graphs, they all have their own standard form, and we're going to look at transformations in both the x and the y axis, and also then look at dilations. I probably won't go through dilations as much, confuse you too much, but at the moment we really want to just look at these graphs, look at the standard form, and then converting from the standard form using our transformations, etc. Now just remember that when you're sketching graphs, really important, we want the x-intercept, we want the y-intercept, and in the case for most of these, we also would like the vertical or perhaps horizontal asymptotes. So yeah, we're going to go through those today, and I guess the first, we might as well just jump into it. Keep in mind that we will have a separate video for circle graphs and semicircles, and I'll also probably do one on what was it, absolute value graphs. But I don't want the videos to go too long. I'd rather let's just sort of keep it to just these three at the moment. So we're going to sketch the graph of y equals minus 2 over x minus 3 minus 4. And I've got over here the standard form for this graph, which is, I guess, a rectangular hyperbola. So what does a standard graph look like? Well, I guess if h was 0 and if k was 0 and let's just say a was 1, then we would have the graph of y equals 1 on x. And you would probably know that you might learn what that shape is. So y equals 1 on x, we've got a graph. This is, of course, the x, and this is the y. And it's going to look something like this. All right, now that's easy enough to recognize, but obviously as we get different questions and they're in different formats, well, we're going to have these transformations, aren't we? So let me just, maybe I'm not sure what color do I want. That'll do. Let's go that color. All right, so keeping in mind that our standard graph for our hyperbola is going to look like that. Of course, if we have a value of h other than 0, it's going to move the graph to the left or to the right. And if we have a k value other than 0, then that's going to move that graph up and down. So, and then of course we'll look later at what this A does. It's going to, of course, cause a dilation. But yeah, I guess let's look at that later. So let's go ahead and sketch this graph. So first of all, if I was to think of the graph 1 on x, let's think about what happens. Let's look at really, really small values. Let's just say a negative infinity. Which isn't really a number, is it? But let's just think of a really, really, really large negative number. What's going to happen? Well, we're going to have 1 on, let's just say, negative 900,000. And what's that going to be? Well, we know that a positive divided by a negative is a negative. We're going to have a very, very small number. So you can see here that, let's just say over here, and this graph is certainly not to scale, this was negative 900,000. Then 1 on negative 900,000 is an extremely small number, and it's basically 0, isn't it? But it will never actually reach that point. Never, ever. And because obviously, if we had 1 on negative 900,000, it's an extremely small number, but it's never going to approach 0, and that's why you notice that we have what's called a horizontal asymptote, and in this case, without any transformations, that's at y equals 0. Similarly though, we're never going to have an x value of 0. Why is that? Because if we have an x value of 0, you might have already learnt that, and if you go ahead and type in 1 divided by 0 in your calculator, what do you get? Well, it depends on what calculator, but you should find that it's undefined. We simply can't take the or divide anything by 0. So the standard form is that we're going to, I guess, we're not going to, the standard form has a horizontal and a vertical asymptote, but with these transformations, whether it goes left or right, up or down, that's going to move those asymptotes. So I guess what are the important things, and I'll sort of just clear some of the board. I'll just pause it for a sec. Now, without working too much, we can actually sort of have an idea of what this graph's going to look like just based on the transformations. Now, first of all, you would have learned that this x minus h, well, in this case, h is 3, so we've actually got a transformation 3 units in the x-axis in the positive direction. And I guess the way to remember that is, I guess, what value is going to give 0 on the bottom. So that value is going to be x equals 3, isn't it? Now the important thing is that we know that initially the rectangular hyperbola y equals 1 on x is going to have a horizontal asymptote at at y equals 0. But what happens is by translating everything 4 units down, then naturally that's going to move down as well. So the first thing I would do is using our standard form, and they're the sort of things you have to know. You have to know what the standard form is, and then so you can apply these transformations. We'll get to the dilations later. So where's the first thing? The first thing we want to do, the first thing, whenever you have these graphs, and that involves a truncus, is we want to find the asymptotes. It's a bit clunky, this thing. I'll have to probably try a different method next time. So we want to find the asymptotes. So the asymptotes are, and I guess these are the sort of things you can rote learn, x minus h, h in this case is 3. So we've got x at x equals 3, we can never actually approach that point, because otherwise negative 2 on 0 is undefined. So we've got, that's the first thing we'll draw. And so we're going to say that there's x equals 3. Now, clearly the horizontal asymptote is usually at y equals 0. Well, that's gone down 4. So we're going to then have y is equal to minus 4. So we've found our vertical and horizontal asymptotes. Now, the thing is, though, is that we've done that. Now, that you always want to apply these transformations first. Okay, so I guess the first thing is, let's find the asymptotes, let's do the transformations, and of course our y equals 1 on x graph has now been moved across to the right 3 and moved down 4. Now we know, then we have to get an idea of the general shape. Now the general shape of course is, I guess, is going to look sort of something like this. All right, now the problem is that we've really got to look at the reflections. Now this negative 2 over here indicates that we've got a reflection. So rather than our original graph might sort of look something like this, okay, well, I guess when it's a reflection, we've got a reflection in the x-axis. Okay, we'll get to later when you've got a negative value in front or over here. Okay, but when we're looking at this value here, when I'm just getting used to this thing, but when this value of a over here, when that's a negative value, that's when we have a reflection in the x-axis. So all of a sudden our shape it's the same, but it's been reflected in the x-axis. So our actual graph is going to look like so. Let's do the correct one after considering our reflections now, and that's going to look like this. Okay, and so on. And by finding those asymptotes and then applying the reflection, so I guess I really should, so we've got transformations, but it's really important. This is where a lot of students go wrong, is that they don't apply these reflections. Okay, so I guess if you're taking your notes, you would note, first of all, the first thing I need to do is find the asymptotes, but you need to know what the standard form is. I guess you've got your standard form, but that's of y equals 1 over x, without any sort of transformations. But you don't really need them, by the way, when it comes to the reflection. It just gives you an idea of what sort of shape it's going to hold. So y equals negative 1 on x is going to look like this, a reflection in the x-axis. We can get to reflections in the y-axis a bit later when we look at the square root graphs. But look, essentially that's all we need. But I guess the one thing that we don't have is we don't have any x and y intercepts. So, and of course we can later find turning points. This isn't actually a turning point. This is what's called a point of inflection. And it's sort of around about here and here. All right, so what I'm going to do now is we need to find the x and y intercepts, and this is something I'm sure that you'll probably be pretty good at. Just remember though, if it's a number of students have already noticed, you start putting these things into your calculator, let's sort of leave them in exact values. Okay, whether it be a fraction, you might need to simplify. But you know, in methods, especially as you go on, maybe you're sort of used to dealing with whole numbers and rounding off decimal places. But the problem is when you do that nice and early, then you might sort of use that rounded off value later, and it can actually affect your results. So let's try and keep things in exact values, and please simplify fractions. Keep the things in fractions. There's nothing wrong with a fraction of 19 over 6. Okay, there is nothing wrong with that. You do not need to convert that to, I don't know, 3.167, because then you actually sort of then you're going to have some rounding errors. All right, so the first thing, of course, was to find the asymptotes. I'm just going to clear the board. Okay, so the second thing is we need to really find out anything that's important to us. We found the asymptotes, we've got the general shape based on the reflection, and now we've got the idea of what the graph is, but it does cut the x-axis and it does cut the y-axis. And from what we could gather, it would cut the x-axis once, and it would cut the y-axis once. So obviously, let's just say, how would you do this setting out? Well, I'm going to say that, I don't know, I'm really funny on the colors. All right, so x-intercept. Okay, let y equals 0. All right, now this is how I would like you to set it out. You might sort of be slightly different, but please make sure that you state this. All right, so I guess let y equal 0, which means that we have 0 is equal to minus 2 over x minus 3 minus 4. All right, now I guess this is the sort of thing where, you know, I wouldn't expect you to do every step. I know that you should be able to transpose formulas. All right, I'm going to get the 4 onto the other side. I'm going to add 4 to both sides, and then I'm going to then multiply that through by the x minus 3. So I'm going to sort of, this is you know, implies that I'm going to go to this step here, 4 outside of x minus 3 is equal to minus 2. All right, so I'm just going to, just for the sake of skipping a few steps, I'm going to then divide both sides by 4, which gives me negative 2 over 4 being negative a half, negative a half, and I've got the minus 3 on the other side. So I'm going to say add 3, 3 take away a half is 2.5, or 5 over 2. So I'm going to basically say the x is equal to 5 over 2. This step here is really important. X-intercept, let y equals 0. Please don't forget that. All right, so we've got our x-intercept. There's just one more thing to find, which is the y-intercept. And for y-intercept, it's exactly the same thing. Y-intercept, let x equal 0. So I'll just go clear the board, give myself some room. Okay, so this time for the y-intercepts, I'm going to let x equal 0, and a lot of the time this is a few less steps. So let x equal 0, we've got negative 2 over negative 3, which is 2/3. 2/3 take away 4. So we've got that y-int is, okay, so we've got y is equal to, I've sort of skipped a couple of steps here, 2/3 take away 4. All right, so we've got a 3 on the bottom. We need to we need this to be a 3, don't we? If we're going to add them, which means that we have to multiply this by 3. So we've got 2 take away 12. 2 take away 12 over 3. 2 take away 12. Negative 10 over 3. All right, so we've got our y-intercept now, which is negative 10 over 3. Now, what I was talking about before, a lot of students might have negative 3.333. Why? It's at the end of the day, if the decimal is going to help you draw the graph to scale, go for it. But you don't need to convert that to a decimal. Leave it in the exact value. Leave it as a fraction, a simplified fraction preferably. All right, so let's go ahead and draw our graph now. We've got our graph completed, and it's all going to make sense. And then now you've got these values, that's when you can go ahead and sketch it. What a number of you do is you start sketching the graph before you found these things, and you find it's all out of sync. Now, when you're doing exams, particularly when you get into Year 12 methods and you have a question asking you to draw a graph, if it is not to a, I guess, logical scale, then things, and let's just say that you found a x-intercept to be 10, and it appears as though on your graph that it looks almost like it's a 2. Well, you can lose marks for that. So negative 10 over 3, this is this point over here. So our graph, which has been reflected, is going to look like so. And this point here is negative 10 over 3. It then intersects the x-axis at 5 over 2. And of course, we had our x and, our vertical and our horizontal asymptote at y equals -4. That's all you need to get your full marks. Just make sure that you are showing you're working with this. Look, if you want to skip a couple of steps, like for example, like what I did, I was sort of doing this transposing the formula in my head. That's okay. All right, we know that, that's maybe in Year 9 or Year 8, I might ask you to show all the steps. But this is the sort of thing that as you get faster at this, you should be able to get better and better at transposing these formulas. All right, so I've done the rectangular hyperbola. I've obviously, covered that in a lot of detail. I'm going to get through the next one a little bit faster. So I'll just pause and clear the board. Okay, so this one we've got the truncus, and the truncus. Let's sort of think of it logically. I don't want you to. Let's just say if you're doing a test, you've forgotten your cheat sheet. You don't, and you sort of get into that habit of rote learning, and then you've forgotten what a truncus looks like. Well, the fact of the matter is that if you think about it logically, 1 over x squared, if I think about 1 over x squared, if I have a negative value of x, then what's going to happen? We're going to square that. Now what's it going to become? Anything squared is going to be a positive value. So what that means is, well, we've got y in terms of x. So if we have any value of x, it doesn't matter, because we're squaring it, we're going to end up with a positive value, because of course a negative times a negative is a positive. Now, because it's squared, there's no way we can have a negative times a positive, is there? All right. The only case where that happens is when we have some constant negative out the front, and in this case, the standard form for a truncus, I guess, without any transformations, dilations, is y equals 1 on x squared, but I guess we want to consider the standard form this thing over here. So this is our standard. I'm just getting random colors here. It seems pretty stupid. This is our standard form. And the only time where we're going to have a positive value of y is perhaps when we've got a reflection in the x-axis, i.e. a is less than 0. So let's think about it. Let's just do the basic one first, though. If I have a negative x value, and let's say it's a really, really large value. Well, a really, really large value, when we're dividing that into 1 divided by negative a billion is an extremely small number, basically limiting to 0. Okay, so you can basically get an idea that it's sort of going to more or less start here, and there's an asymptote at y equals 0. Then as we get, let's just sort of say a number really, really close to 0 on the negative side. So let's just say negative 1 millionth. Okay? We've got negative 1 millionth. Well, now remember, that's our x value here, negative 1 millionth. Now what's going to happen? We've got, let's just do it, we've got y equals 1 on negative 1 millionth. I know it sounds stupid, but you can actually just think about it logically. All right, negative 1 millionth. And then we're going to square that. Now what's going to happen? If we square that, we're still going to get an extremely small number on the as the denominator. Now if we have 1 on an extremely small number down here, then we're going to have a really, really big number, i.e. it's going to be approaching infinity. So that's going to give you sort of an idea that this is an extremely large number, and you can actually get the idea that, okay, this is virtually 0, this is improving, and then at the same time, same thing, for a very, very small value of x, but in the positive, then we're going to have a really, really large number. 1 on a very small number is a very large number. So, of course, over here. Now remember that if we have x equals 0 on the bottom, that can't work either, because it's going to be undefined. So, we're going to get the idea, and you could actually, I guess, come up with this yourself just by using your head rather than just doing the rote learn. Okay, it certainly helps to rote learn things in mathematics, but you really want to be able to sort of think outside the square. Oh my God, I forgot my cheat sheet today. You shouldn't really need it. And at least that will help you remember, I guess, in some way if you sort of understand it at a deeper level. All right, so the truncus. Now I've been through the transformations. Let's just make this sort of nice and quick. I want to sketch a graph of y equals 3 over x plus 3 all squared minus 6. All right, so let's do it. Okay, first of all, we know that the graph, that's not going to work. We know that the graph is going to look without translations like this. And translations. I don't know where I was getting transformations. Translated. Oh, it's just too late. Anyway, so we know it's going to look like that. So without our value of a, being less than 0, it's actually going to look much the same. It's just it's going to be moving up or down. So the first thing is, though, we would like to find, over here we have a horizontal asymptote without any translations. I don't know why I said transformations. What an idiot. All right, so we've got like this. We'd still have two asymptotes. So what's happened? Our graph has been translated now remember it's x minus h. X minus h is our standard form, yeah? Well, isn't that the same as, well, 3, x plus 3, isn't that the same as x minus 3? It is, isn't it? So that's one way you can sort of, I guess, get around these translations, x minus 3, which means that it's translated h units. So h in this case is minus 3. So it's translated minus 3 units to the left. So without even drawing anything, so it's 3 units, I'm just going to say left. And of course, it's translated 6 units down. 6 units down. All right, so without sort of drawing any to any scale, we know that this asymptote over here is actually going to go 3 units to the left. So I'm going to draw that. And we know that that's going to be x is equal to negative 3. Of course, y equals 0 now becomes y equals negative 6. Certainly haven't been drawing this to scale. Don't draw as bad a graph as this, please. Negative 6. All right, but the thing is that there's no reflection in the x-axis, or the y-axis for that matter. So what we're going to do is we're going to just draw our graph. All right, we're going to draw it now. Before we sort of find anything out, let's just go ahead and do it. Let's draw our graph in. I don't know what's going on. Okay, so it's going to look like this. Okay, now why is it going to reach the value of 0? Well, because it's been moved across. All right, we can have a value of x equals 0. Okay, down here we can have a value of x equals 0 because x can equal 0. Because 3 over 3 all squared is 1/3. All right, we can certainly have that, but we never can have anything over 0. All right. Now remember that because this can never equal 0, then that means that we can never have this value of negative 6. This has to equal something at least. And if it equals nothing, well, we can't have that because the only way it can equal nothing is we have nothing on the bottom. So what I guess we've got our values. Let's go ahead and we've got our graph here. We've just got to fill in the one last thing. We've found the asymptotes. Now we have to find the x and y intercepts, which we've been through before. But I'll do it very, very quickly. Okay, so we've got for the so we've got to find x-intercepts. X-int. I'm going to let y equal 0. And which means that we have 0 equals 3 over x plus 3 all squared minus 6. All right, so over here we've got, let's get 6 on the other side. Adding 6 to both sides gives us like so. All right, I'm going to, I don't want this x plus 3 all squared over this side, so I'm going to multiply both sides by x plus 3 all squared, which of course that's going to cancel that out, isn't it? Okay, and over the other side we're going to have, so what we're going to have is 6 over 3. we're going to have 6 x plus 3 all squared is equal to 3. All right, so you'll notice that finding the x-intercept is usually just a few more steps because we have this square and we've got to solve for x, not x squared. All right, so let's get divide both sides by 6. And I'm going to do it over here because I'm running out of room. Look, these things are good, but as far as showing you working on my little computer doing these videos, it's not very good. So we've got x plus 3 all squared is equal to a half. All right, so if I've got a plus on one side, I've got to do the opposite. Well, what's the opposite of a square? It's a square root. So we've got to square root both sides. So let's go ahead and do that. So the square root of x plus 3 all squared is just x plus 3. And that is equal to the square root of a half, which is 1 on root 2. All right. Now what has happened here? When we're doing the square root, all right, the square root of x plus 3 all squared is x plus 3, but what are we missing on the right-hand side? That's right, we're missing a plus minus. All right. Now, I want you to think about this plus. Why is it plus? If you're sort of thinking, why is it plus minus? Well, I'm going to ask you this. Negative 3 squared, what does it equal? Negative 3 times negative 3 is 9. And of course, if we had the same thing, positive 3 squared is also equal to 9. So whenever we're doing the square root, we're doing the square root of an actual number, then we have to consider both the positive and the negative. So the square root of a half is two things, because negative 1 on root 2 times by itself, or squared, negative 1 on root 2, that happens to be a half. And of course the positive values also hold. So this is one thing that we really have to make sure of, and this is where a lot of students go wrong, is that they just sort of leave this. And look, it's going to be quite obvious at the end. If you actually use your brain and see that, oh, it cuts the x-axis in 2 points, means that we're going to have 2 solutions anyway. So that's the sort of thing, if you're rote learning, maybe you'll miss this step. But if you think and you have a look at the graph before you go on and move on and say that you've got it all, well, we've got 2 points. So let's have a look. So clearing that off, we've got x int let y equals 0. You've got all your working, which you wouldn't have rubbed out. I've had to do it to create some room. So we've got our x ints. X int. Well, we've got 2 values. We've got negative 3 plus 1 on root 2, and our second value with a comma is negative 3 minus 1 on root 2. Now a lot of people will put in your decimals and stuff, that's okay, but there's no reason why you can't just leave it as that. All right, if you want to get an idea of how far they are each side of the asymptote, go ahead and work out the decimal. But look, if you were to write these values, this is negative 3 minus 1 on root 2, and this is negative 3 plus 1 on root 2, then that's fine. Obviously, for the y-intercept, then we just let x equal 0. So I'm going to say y-int, we're going to let x equal 0, and that's going to work out pretty well though, isn't it? We've got 3 over 3 squared, which is 1/3. 1/3 take 6, which is going to be, well, 1/3 is the same, or 6 is the same as 18 over 3. So 1 over 3, take 18 over 3, is negative 17 over 3. Once again, go ahead and label it there, and you're done. So remember, with this, it's the same thing. Know what the standard form is. Make sure you apply the translations and then of course any reflection in the x-axis, y-axis. We'll get to sort of that later. And then away you go. Find the asymptotes, which we've done. We could actually draw the graph just by looking at it, but then of course you need to work out a few things. You need to work out the x, the y-intercept, and I guess later on we may have to work out turning points and things, but we'll get to that later. Alright, so do apologize, it's taking much longer than I thought. I'm just going to clear the board and we're going to go through one last example. And in the next video, we will go through a lot of the circle stuff, which will help you with your homework tasks that you have. Okay, I'm going to be super quick this time. I said it last time and it bloody went forever. So I do apologize. We're going to do this graph. Okay, now let's think about some real standard things first. First of all, a square root graph. Well, you can't have the square root of a negative number. So if I had y equals our standard graph of y equals the square root of x, well, if x is negative, then you put that in your calculator, you will find that it's undefined. For those people doing specialist, sort of a slight exception to the rule there. We'll get into complex numbers. Those people doing specialist next year, you'll learn about that. But as far as you methods kids understand, that we can't find the square root of a negative number. So what does that mean? It means that we can't, the standard graph without any translations is that we can't have any negative x values. And can we have x equals 0? Yes, we can this time. It's not an asymptote. Okay, so I'm going to draw a big circle there. Now what happens is, let's think about our square roots. Square root of 1 is 1. Square root of 4 is 2. So, you know, I guess what we're looking at is we've got the perfect squares. We've got 1, 4, 9, 16, 25, 36, 49, and so on. Up to 10, we've got 100, 11 is 121, 12, 144, 13, 169, and so on. So what's happening though is these values, okay, when x is equal to 1, well, we've got sort of 1, and then when x equal to 2, we've actually gone up by a factor of 4. So I guess that but eventually it sort of peters off. So it's sort of a graph that sort of looks something like that. Now remember that, you know, if we had the square root of an extremely high number, then y is going to get extremely high. Okay, so this would actually go on forever and ever and ever and get slightly bigger until, and of course, you know, we can look at the domain and range. Well, what is the range? It's, in this case, the range is from 0. The range is the element from 0 inclusive to infinity. All right, but the domain is only the domain. Well, it includes 0, and we can go all the way up to infinity. All right, so that's looking at the graph. That's going to give you an idea of the shape of the graph. Okay, but let's just say we know what this graph looks like. We're going to start applying these transformations. Let's have a look at the transformations over here. We've got translations. I'm just not thinking. I've just got it in my head. So translations, we've got a translation of our standard form is x minus h, so we've got a translation of 2 units to the left. And we've got 3 units down. Now, if I use a different color pen, that's going to give us an idea of what the graph's going to look like. But remember that once we try and apply the translations, we're then going to apply any reflections. Do we have any? Well, no, not at this stage. So we're going to get a pretty good idea of what this graph's going to look like. Now, our standard graph's going to look like this. So we're going to move that 2 units to the left and 3 units down. So, okay, let's just move that, and it's sort of going to be something like that. But if we then move that down, let's just say here, then what's that going to do? Well, where's it going to cut? Oh, I'm just going to sort of take a stab at this. All right, so we can have negative values of x. Why? Because we can go all the way up until what? Minus 2 plus 2 is the square root of 0. If we had minus 3 though, minus 3 plus 2, and square root of that, negative 1. Well, we can't have that. So in this case, we can have values of x up until negative 2. So let's work out sort of, I guess we've worked out our graph. Let's go ahead and we know that this point where it starts is at, we can give a coordinate, can't we? Negative 2, negative 3. I'm going to say that's where that graph starts. All right, and let's just say that that's there for argument's sake. Let's just say y-intercept x equals 0, 2, root 2, take 3. All right, so it's going to be look something like this. Not a very good drawing. And we can, this is the one thing that we're doing when we're doing the square roots, is that we can actually have, this is an important point. All right, now of course we've got to find the x-intercepts and then the y-intercepts. Are there any are there any asymptotes? Well, there's not an asymptote as such. Just sort of like it's just the domain has changed, but there's no asymptotes because this point is inclusive. We can actually, the point negative 2, negative 3 exists. Now we're not going to really draw an asymptote over here because it actually includes that point. So there's no asymptotes for the square root graph. All right, this is just going to go forever, but this point is inclusive. So asymptotes are only for when we don't reach a certain value. All right, so x-intercept, I'm going to try and do this really small so I don't run out of room and have to clear the board again. X-intercept, y equals 0. So we've got 2x plus 2, and I'm going to just skip a step, is equal to, I'm going to get negative 3 over the other side. We're then going to then say, I'm going to do this. And you can do this if you like, as long as you don't make sort of any errors in the way. I'm going to just sort of say, let's just get that over the other side, 3 over 2, let's square it. Square both sides, we've got x plus 2 is equal to plus minus 3 over 2 squared, which is 9 over 4. Okay, so our last step then, I guess, is that x is equal to minus 2 plus minus 9 over 4. I won't get into simplifying the fractions. I would expect you guys to do that. And you're probably thinking, what the hell's going on? Well, what is going on is that, remember that it's only when we're doing the square root of something when we're doing the square root of something, we have to consider that. Well, we don't have to do this, all right? And this is the thing, you might go ahead and do that and then as a mistake, and I've seen students do it. So remember though, if you look at the graph, how many times does it cut the x-axis? It only cuts the x-axis at one point, which means we'll only have one solution. So if you've got something like this, and I sort of will do this sometimes, I'll do these things just to throw you off. It's really important that if you do something like this, you have a look at the graph and you use your brain. Your brain is telling you that it only crosses once. Well, that means that there's only one solution. So this 9/4 plus minus, it's just 9/4, isn't it? All right, so it's 9/4, take 2. 2 is the same as 8/4. So we've got 9/4, take 2 is 1/4. All right, so this point here, that wasn't too bad actually. X is equal to, so that's our point 1/4, 0. And of course, then you can do, look, I'm going to get you to go do the y. Yep, let x equals 0. It's going to be 2√2 take away 3. Okay, which means it's actually going to be a negative value, a fairly smallish one, and that's going to be 0, 2√2 take 3. All right, so we've gone ahead and we've done a graph. Remember though that we don't, unlike the truncus and the rectangular hyperbola, we don't have to do an asymptote for the square root graph. However, we do need to know the point at which it starts. But that point, -2, -3, is inclusive, so there's no such thing as an asymptote. Then, of course, you need to find the x and the y-intercept. And of course, before you go ahead and do anything, if you do something silly like this, make sure that you look at it and go, is that logical? Why do I have two solutions when I only have one x-intercept? All right, so just be careful about that, and that's why I sort of included it. And then once you do that, remember also that be careful about if you have this, a negative sign here, well, all of a sudden things change. All right, it's a reflection in the x-axis, and it's going to look, well, exactly how that. Let's do a big line here. A reflection in the x-axis is going to be exactly mirror image, and I guess that mirror is on the plane of the x-axis. All right, look, I hope that helps. Look, I'm sorry it's a long video, but that really should cover most of the concepts from 5A, B, and C, probably in more detail than you needed. I'm sure most of you are fine. You probably all left about 35 minutes ago. But look, we'll leave it there, and in the next couple of lessons, we'll go through absolute value and circles. Thanks. Study hard.